Hi everyone, this is Dave Clark of EXE Consulting, and it's March of 2024. The subject of this video is the Regency Synthesizer by nakst, N-A-K-S-T, N as in Nancy. In this video I'm going to confine my remarks to the generation layers, or the generator layers, in the Regency Synth. These three boxes, and then these two knobs, and the unseen input at this end, and the unseen sinusoidal oscillator at this end. The thing to do might be to start out with the Casio patent from 1987, 4658691. The keyboard generates signals that are turned into frequencies that are fed to the phase angle, and that phase angle result is sent to a waveform synthesizer. In the case of Regency, that's a sinusoidal oscillator. Notice that this goes from essentially from left to right. In the Regency Synth, we go from right to left. What comes in here on the right hand side is a ramp up like this that repeats itself over and over again. And this is synced to the period of the sinusoidal oscillator over here, the unseen oscillator, so that every time it goes from beginning to end, in this case going from 0 to 1, this will go from beginning to end. Now I'm going to change this so we have a ramp down to explain what these do. The ramp up says read this from beginning to end. This ramp down says read from end to beginning. So it's the opposite, going in the opposite direction of this to read this signal. The ramp up tells how to read this one tells how to read this one. In the case of distortion amount being 100%, that's true. Now if I change this to 50%, it's going to read 50% according to ramp up, 50% according to ramp down. If you add those two together, you'll get a value of 1/2 straight across, which would say to sit here and read this value, one value after another, the same value, and it essentially gives a DC signal. But at 100%, this is going to say to read this backwards. This then says to read the next one. If it was turned on, it would say to read this next one, going from the midway to the end, to midway to the beginning, back to the middle. But right now this is set at 50%, so it would take, and this one's set to 0, so this actually feeds an argument directly over to the sinusoidal oscillator. It doesn't actually read this, so it's not modified by this. If this is 0, 50%, it's going to read 50% down and 50% backwards sinusoidal. So I've plotted out essentially what these are. The first one is the ramp down. The second one is the backwards sinusoid. And then the combination of these two, 50-50, is going to give this down slanted kind of sinusoidal sort of thing. Now in the case of this downward slanted kind of sinusoidal waveform, because this is turned off, distortion amount 0, this is actually going to be the argument that's fed to the sinusoidal oscillator. What the sinusoidal oscillator does is takes these values and multiplies them by 2 pi and then takes the sign. So here we have 0.75 is what this value actually is, times 2 is 1.5, times pi radians gives us 1.5 pi radians. And if you take the sine of that, you're going to get -1. The next value is down here around 0.36, for which you would get a positive value of 0.77. The next one is 0, so we're back at 0. Then the other one here is 0.64, I think it is, which gives you minus 0.77, and then finally 0.25 times 2 times pi, and then times pi radians, and taking the sine of it, you get 1. Now what I'll do is I'm going to address the phase knob. This goes from 0 to 1, or 0% to 100%, and essentially is added to whatever comes out of this calculation. So previously we had 1.5 pi radians, and what we're going to do is we're going to add pi radians to that. So we'll have a different result. As it turns out, that different result is actually plus 1 for this value. When we come down here, the result happens to be minus 0.77. So you see what's happening is it's as if it's going backwards through this particular signal. That's what's going to come out if we have the phase set at 50% or offset by pi. In case you're wondering where the negative sign came from that turns this signal around, it comes from the trigonometric relationship for sine of A plus B, where you're adding two angles together. In this case, B is pi, so it's sine of A plus pi. If you work that out, look that up and work it out, you'll get minus the sine of A. So whenever that's 50%, whenever the phase is 50%, you'll be turning the signal around that comes out for this particular example. I think what I'll do now is just demonstrate the two different signals, this one coming out and then the reversal of it. And it might be hard to see, but it'll be down here in the lower right hand side. The signal is going up, down, then it drops. Up, down, up, and drops. If I change the phase to 50%, it goes down, up, down, and then up. Down, up, down, and then up. So that's how that works, just to show the difference. Okay, for the final part of this video, I'm going to show what the sync amount knob does, or explain what it does. And basically the sync amount causes more than one ramp up per period to come into this processing. And in this case I've turned everything off, so it would just go straight, become the argument, straight to the sinusoidal oscillator and become the argument for it. 2 times pi times whatever the argument is. It'll just ramp up from the sinusoidal argument. Total will ramp up from 0 to 2 pi, 0 to 2 pi. Since this is set to 0, this formula for this sync amount to give you the number of ramps is 7 sync amount squared plus 1. Right now this is set to 0, so 7 times 0 squared plus 1 is 1 ramp. As it turns out, if you work this out at 38% or thereabouts, it would give 2 ramps. At 64 point something percent, just below 65%, it gives 4 ramps. And at 100%, it gives 8 ramps coming in per period. So if you think about it, this should produce a sine wave that is twice as high as this one. So that's one way to change the octave. And of course, it's better to do it over here. It's cleaner over here because you can get exactly the right amount. So put it back down to 0. But you can also get, with this sync amount, you can also get fractional pieces. What I mean by that is, let me just add in, show you an example here. It'll look like that. 1 and a little bit. If it's up in here somewhere, it'll give you 1 and a little bit. In order to demonstrate this, I think what I'll do is just turn this distortion amount up and leave this at 0, so I'm mimicking what this sync amount will do. And I'm going to play a note here. So you can see it's added some distortion. So it's basically what it does. Thanks for your attention. I hope that this helps to explain a little bit about what these generators do. The rest of the things are pretty, I think, straightforward here: volume, pan, coarse, and fine. So again, thanks for your attention.